for the, so we're going to start the live stream now. So for the benefit of the live stream, I'd like to kind of introduce this. So we have Josh Woodward here from the GDG Fresno, who is also a member of the GDGX project. And the GDGX project, well, he'll talk about it some more, but let me just say it's way cool. We got a bunch of organizers, not just here in the US, but from all over the world that have been working on several open source projects on GitHub. And one in particular that just launched on the Play Store, the Frisbee project, is an application that you can use here in Silicon Valley to see what's going on with our GDG, but also with the East Bay GDG, the GDG in Fresno, GDG in San Francisco, actually a GDG anywhere in the world. I don't know if you realize it, but we have GDGs in more than 100 countries to date. And this app actually locates you and tells you what activities around the GDGs is happening where you are. So if you're traveling, you know, to the East Coast and you're kind of bored and you want to find a GDG event, you can look it up. So he's going to talk about that tonight. And I'm very proud of these people that they're volunteering their time above and beyond their organizer volunteer time already to work on these projects. They're not being compensated in any way for this. It's a free app they're giving out. And I guess I'll just turn over to Josh. So take it away, Josh.
I'll use this one. Yeah, I'll just use this. Okay. Because I didn't, it's just, it's a slide. Yeah. We don't have sound stuff to it, huh? Or do you have a... Hey, is there a sound plug to this one? Because I was going to play the...
Oh, we just have to do this now.
Oh, okay. Yeah, I'll do it that way. Yeah,
We could try. Jamie,
do
do you know if he plugs into the sound from the podium, will you get it?
I'll just do the microphone. I can just do the microphone. I'll just do the microphone.
I mean, if he plugs into that? No, don't know.
Either way.
So just do it that way?
Either way.
All right.
Yeah, we'll just leave it. How do I do that?
Are you on full screen?
Yeah.
Get out of full screen.
Oh, you're not mirroring.
No. There we go.
Okay. So like Van said, my name is Josh Woodward. I organize GDG Fresno, which is like 2.5 hours away from here. Back at Google I/O last year, we have a GDG Organizer Summit where all the organizers from all over the world come and share ideas and stuff like that. And every year at this summit, all the organizers say, you know, we need a tool to do this and we need a tool to do that and help us organize our chapters and stuff like that. So I've been doing this for over 3 years now, and I hear the same requests for tools. So through I/O, I met, you know, other organizers and stuff, and we got together and we decided to actually do something now. And so we came up with GDGX. So let me show a little video here that one of our members made. It's pretty cool, so let's show that real quick. Okay, so that's just like a little teaser video. We like to just like have fun and stuff. So I call ourselves like a covert ops team because there's like over 400 organizers. Well, over 400 groups, over like 1,000 organizers, and we're a group of like 15 of them. And so we work in secret and build these little projects and stuff like that. So I just make fun a little bit. So why GDGX? I think it's fun. You know, it is a play on the Google X project. We're not building Google Glass or self-driving cars, but when you're doing this stuff in your spare time, building a website is a pretty big project. So, and then Louis Gray said that it's not just X, it's extreme. So I had to throw that quote in there. That was funny. He put that on one of his videos. So some of the projects we've done is Project Glider. It's just the Google I/O HTML5 slides rebranded for GDG. We have a project called Boomerang, which is a boilerplate website template for the GDG organizers, and Project Frisbee, which is the Android app. Like I said, Project Glider is just the I/O slides rebranded. It's not mirrored here, so I got to look over my shoulder here. But it's like the Google I/O HTML5 slides. We just rebranded them. So this is all HTML5. Just real easy. Let's see, what else? Oops. Okay, and then Project Boomerang is one that I was like the lead on and I worked on. It's a boilerplate for the other chapters to easily build a website from nothing, really. So here's GDG Fresno's website. And so it pulls all of our information from Google Plus and stuff like that. It pulls news from Google Plus. These are all Google Plus posts that just get fed into the website. And all of our events from the Google developers site, past and future events.
That's a lot of future events.
We got 4 planned. Our Dev Fest is in there, and I think we have a recurring Learning Android with Android Studio. So that one's a repeat event that happens every month. And then it pulls photos from Google Plus. So it's real easy. All someone has to do is change 3 variables, and they have a full website. It's always up to date because it's just pulling content from Google Plus or the developers.com site. It's written in AngularJS and Twitter Bootstrap. 3 lines of code, and they can deploy it. It's all front end, so they can deploy it anywhere. You can host it on Google Drive. You can host it on Google App Engine, whatever. And we also built a Yeoman generator, so it's even easier to deploy. You just have to answer 3 questions, and you get a build script that builds out your website for you. So now this is the reason Van invited me to talk, was Project Frisbee. This has been a very popular release. I think we released it a week ago, and it already is over 1,000 installs and stuff like that, so it's pretty cool. It's a GDG Android app. It is location-based, so you can open the app. Say you travel a lot and you're sitting in your hotel and you're bored. Maybe there's a GDG meetup going on nearby. You can open up the app. It sees you that you're close to Boston and there's a GDG in Boston, and maybe they're having a meetup. You can go visit that meetup. We also added all the upcoming dev fests to the app. So say you want to travel somewhere else to visit a dev fest, because the dev fests are the larger events. You can search through all of the dev fests on your Android app and find one and book some tickets and fly, I don't know, whatever. We also have all the Google developers live videos on the Android app, sorted by category like Android, Chrome, Cloud, stuff like that. and I'll show you some screenshots here. So the app is live on the Play Store. If you have an Android device, you can go to this URL, gdg-x.com/frisbee, and it'll redirect you to the Play Store app, and you can download it right now. And here are the screenshots for that. So this is GDG Fresno, maybe hard to see in the back there. This is GDG Fresno loaded, the info about it. So it shows like the organizers, the about, and some links that we have. There's all of our events, future and past events right on the Android app. There's the DevFest screen, so you can find all the DevFests that are coming up. There's the Google Developers Live screen, and that's the Android page, so you can quickly watch videos from Google Developers Live right on your Android. And then there's the list of contributors. So this is a global effort. We have translations in, I don't know if that's the language, but Ukraine. The Ukraine guy translated it. We have Spanish, French, Russian. A lot of help has gone in from the other organizers to translate the app for us. So GDGX as a whole, we have like a board now so that we're kind of like organized and structured. And then we also have a lot of people involved. Kevin's up there, but he doesn't do anything. He doesn't do anything. And that's GDGX. Was that 10 minutes?
Any questions for Josh?
Oh, yeah, I guess so.
There you go.
One question. Oh, yeah, sorry. I think I ended it early.
Yeah. That was the GitHub picture in the last slide.
That was, huh? Let's see here, real quick.
That last slide might have the...
I think it was all on there. I prematurely. Forgot about the last slide. Okay, so yes, you can contribute, you can look at all the source, you can do everything on our GitHub page. You can circle us on Google+, and we have a YouTube channel that we upload videos to and stuff like that. Post the slides. They are posted. It's gdg-x.com/gdgsv.
So just quick housekeeping. Yeah, thank you, Josh. Quick housekeeping before Wes hops up here. Just remind everybody to turn off their cell phones so there aren't any interruptions. And then the restrooms are around the sides over there if anyone needs that. And make sure that you're welcome to take pictures and things in this room, but outside of this room, don't do that. Remember, you're a guest. Don't take pictures outside of the room. Don't bother the people trying to work and things like that. Mm-hmm. We'll let Wes.
And I just want to remind people we are live streaming tonight, so if it's a short question, and Wes is open to questions while he's presenting, he'll need to repeat it. If it's a longer question, you'll probably want to go to that mic, and we actually get to the Q&A at the end. I would really ask that you use the mic so that anyone on the live stream can also hear the questions. All right, thank you.
Okay, here's Wesley.
Thank you. Wait, I have to get the right talk first. I think this is the right one. Let's see. All right, welcome to DevFest. I'm just kidding. No, seriously though, DevFest season is coming up. We're really excited that we're going to have these events again globally around the world, supported by the GDGs, such as yourselves.
This will be a talk that some of us on the team have designed to be delivered at GDGs around the world. And I'm just giving one sample delivery of it so that people get an idea of what the talk is all about, you know, the vibe and things like that. So that's what I'm here for. All right, so tonight we're going to talk about Google App Engine and give you an overview of other cloud computing products, whether they're, you know, part of our cloud suite or other products that Google has. I'm Wesley CHUN. I'm a developer advocate on the developer relations team. And are we all ready to get started? All right, you're supposed to say, wait a minute, this guy has a collar on, can't trust him. Okay, people with collars, right, very scary, so all right, let's get real here. Okay, I have to wear my developer wear. All right, now you can believe me, right? Okay, cool. So years ago, I would say 3 or 4 years ago, you would have somebody on my team come up and give you a talk on App Engine and introduce you to cloud computing and tell you what App Engine is and hope that you get on your way. That was the case a couple of years ago. But since then, lots of changes have happened. Most notably, we can't just talk about App Engine anymore. That's not the complete picture. It used to be our only cloud product, you know, but now we have a lot more things. We actually have a real platform, okay? So App Engine is just one component out of many different cloud services that we have now. You know, so the cloud platform team asked me to, you know, say a little something about the platform just so that people are aware of it. I'm very happy to do so. So, you know, just because I'm talking about App Engine tonight doesn't mean that you're limited to just that one particular tool. There's plenty other ones, all right? So, and hopefully, you know, as the year goes by, you'll be hearing talks in each individual one of these products because they're all pretty exciting in their own right, okay? So a little bit more about me. I'm a software engineer. I've been an engineer for 25 years now. I'm getting kind of old, actually. If you don't believe it, how many of you guys know what punch cards are? All right, I learned Fortran on punch cards. That's my age group. All right, so I'm just like you guys. All right. One of the, I guess, a little bit more about me, the thing that I built that most people know about is I was one of the original engineers that built Yahoo Mail about 15 years ago using Python when no one ever heard of it before, and we created our own web framework before that term even existed, so that was pretty fun. Worked at all kinds of other interesting places. Probably the strangest thing that I've done is using Python to work on software for doctors to help them analyze patients with spinal fractures. So talk to me about osteoporosis later. All right. Men get it too. All right, don't think it's just a woman thing, all right? So work out, do weights, don't smoke. All right, those things are all good for your bones. I'm also a writer, so some of you guys may know Python. Anybody out there, Python? Yes, yes, yes. Okay, then you may have seen or heard one of my books. I like to write, which is kind of weird because typically engineers don't like to document their code, much less write a book, so I'm one of the mutants out there. Another thing that I like to do is I've been teaching for over 30 years now. So this is my I think 30 years ago exactly, I got my first paycheck as a teacher. So I've been teaching locally. I give talks at conferences. I'm part-time faculty at Foothill, which is close by, but I really like teaching and talking to people and getting developers excited about technologies. But enough about me. This talk is actually about you guys, so hopefully you're some sort of developer or a tech lead or some sort of tech manager, product manager, entrepreneur, QA tester, product manager, something like that. You're curious about, or you're new to Google Tools. This may be your first meeting. Whose first meeting is it here today? Wow, great. That's roughly about a third. So welcome everybody. Glad that you can come and hope that everybody makes you feel welcome. Don't feel shy. Go talk to people because, hey, they may be doing something that you may be interested in hearing about, all right? Or you want to know more about the Google Cloud Platform. So I'm going to start there. I'm going to talk a little bit about the platform first, then go into App Engine, and then kind of like talk about how the whole ecosystem works, and then what other Google tools and services are similar that you may want to consider for applications that you may want to build. All right, so here's the structure of the talk. It's really broken out into 3 main parts. Give a little bit of background motivation as to why we're in the cloud business, why App Engine was created, things like that. Then most of the talk will be focused on the App Engine product itself, and then I'll talk a little bit more about each of the other cloud platform tools that I think you should look at, as well as other services from Google that are not part of the cloud platform, but they're cloudy in nature. All right. And if there's lots of time permitting, I can start doing some hands-on coding as well, but at least I'll point you to a place that you can get started with. And due to the hard work of one of my coworkers, you can actually start playing around with App Engine without doing any downloads whatsoever. You can just go straight from a browser window to the website and start playing around with App Engine. So I think that's a really exciting change. And it just reduces the barrier of entry for people who want to just try and play with the platform. All right, so that's really the structure of the talk tonight. All right, so let's talk a little bit about scale. I know some of you guys are going to know the answers to these because these numbers were released around I/O timeframe. So I know you guys keep your ears and eyes open to Google News every single day, looking for information. But in case you don't know some of these numbers, I want you to start thinking about googly-sized numbers. Like, if I was to ask you on a random day in 2012, what do you think the size of our search index is in terms of bytes? What would be the kind of number you would say? Another question I want you to think about is, well, since we're talking about numbers, how much video do you think is uploaded to YouTube in terms of hours, every minute? All right, how many hours of video are uploaded to YouTube every single minute? That would be a number from this year, from Google I/O, of course. And then since we're talking about YouTube anyway, how many people on this planet this year watch at least one YouTube video a month? Or at least their IP address does. All right, all right. So think about that. And then as you're thinking about that, and I start talking about the App Engine product, I'll ask you a related question, which is, how many hits do you think App Engine gets across all of its apps every single day? And by that, I mean like page views or just any HTTP, GET, post, or whatnot. All right. So those are some numbers that I want you to think about. I will go over that halfway through the talk. And then the other thing I want you to think about is, how many times have you gone to like google.com and not have it respond, or gotten an internal server error or some other 500, right? Probably doesn't happen all that often. Maybe a couple of you may have seen some of those, but really they're very rare. And the reason for that is we have a staff of people who are up around the clock to make sure that the system is up and it's responsive. All right, so that is the kind of reliability that you would love to have for your own apps. Right? I mean, just takes away some of that worry and give you peace of mind that you want. Okay? All right, let's go back to the top. What's a good approximate size of our search index around last year in terms of bytes? Anybody? Rough number? 100 bytes? 100 million? A terabyte? A petabyte? What's the difference between a terabyte and a petabyte anyway? It's a P, a T, an R, right? Petabyte is another 10 to the 3 higher than that, all right? So in 2012, it was 100 petabytes, but I like to say 100 million gigs because that's sort of easier to kind of understand, because once you start using, peta, exa, all those things just become mumbo jumbo, right? So you really want to start thinking about things like that, all right? How about YouTube? How much video is uploaded to YouTube every minute? 6? 10,000, 7. Okay, let's just round it off for 100. Okay, 100 hours a minute, which is roughly about 4 days worth of video. Now somebody, when I gave this talk earlier, somebody asked a question that I couldn't answer, which was, what percentage of those 100 hours are cat videos? Okay, I'm sorry. I mean, we may have some machine learning code that has figured that out, but I haven't been told yet. All right, so I'm sorry I can't answer that question. How many people on this planet watch at least one YouTube video a month? Not that many, just 1 billion. It's a small number, all right. All right, so those are just some numbers. So I'm planting the seeds to have you think about scale. That's the point of this slide, okay? Then another thing I want you to think about is, oh my God. So not only do we have out-of-this-world scaling, but we also have out-of-this-world innovation and security. So you can tell that's out-of-this-world security, right? That's actually a street view picture from one of our data centers. This is probably the one in North Carolina. This one is what our data centers look like with a professional photographer. All right, that's Iowa, I believe. So you can find these all online. You can use them actually as backgrounds for your computer if you want. They're actually very pretty, but in reality, on an everyday basis, they kind of look like this. Okay, because I know I've been inside a couple of them. All right, they're more blasé, but actually that one looks really good. So Anyway, so just kind of keep in mind the scale that we have, all right? The other thing is innovation, all right? So Google has spent many, many years building a lot of technologies that have really launched the era of big data. You know the names MapReduce, you hear Bigtable, you hear all these things, but when you realize that those things are 6 years old or 7 years old, it kind of blows your mind, right? And now, we've moved beyond these technologies. Google File System, all of these things, we're moving beyond them. Now we've got newer technologies, Dremel, Spanner, Colossus. That is what's going to take us to the next level, all right? Same goes for you guys. As we come up with these innovations, we make them available to you guys, and you can use them to build your next awesome app with, okay? All right, so before we start talking about cloud products and things like that, let's talk a little bit about service levels, because what happens is, as I kind of like roam the hallways, maybe not here, but in other places or at conferences, I hear people talking about cloud computing, it's a big deal, and they throw around SaaS and infrastructure and all these words, and sometimes people don't really know exactly what they're saying, except they're just trying to make their conversation buzzword compliant. All right, that's fine if you think you want to sound like you know what you're talking about, but I think there should be a better understanding. So the purpose of this slide is to make sure that we're all on the same page as to what is a cloud service level, what products work at those levels, so that when you do want to talk about one product versus another, one vendor versus another, that you're actually making the appropriate connections and comparisons, instead of just saying something like, ooh, should I use App Engine or should I use EC2? Right? Because that question doesn't, people used to ask that all the time, but that question doesn't make sense, because that's an apples versus oranges type of comparison, because both products serve very different levels. All right, so just to kind of get everybody on the same page, if you already know this stuff, I apologize, you'll be a little bored, but just kind of hang with me here, and then we'll move on. Okay, so at the highest layer, we have software as a service. That simply describes an application that requires you to have a web browser to access. That's it. Right? If I'm a user of Yahoo Mail, Hotmail, or Gmail, I really need to have a web browser to access them. Unless, of course, I have a mobile version, but still, it's not running on your server, in your home, in your lab, or whatnot. You're not maintaining your own mail server at home because you've decided that, hey, you know what, that's too much trouble. I've got to run an IMAP server, SMTP server. I really don't want to do that in my house. I just trust one of these third-party vendors like Yahoo, Microsoft, or Google to handle my email for me. All right, you are outsourcing your email to a third-party vendor, and that's what those apps are. All right. Of course, you notice that you don't have control over that code, right? If you find a bug in Yahoo Mail or in Google Apps or something like that, you really need to file a ticket, because it's the vendor's responsibility to manage that source code. Same thing goes for Salesforce and NetSuite and all those. Those are all software as a service. All right. At the very bottom layer, we have infrastructure as a service. That's where you just said, you know what? I'm going to outsource everything, because I just don't want to have anything on premise. I don't want to maintain my own labs, my own machines. I'm just going to rent hardware from Amazon, Microsoft, Google, or whomever, right? So I'm getting virtual machines, or I'm renting big disks, and hopefully as a paying customer, I'm going to get all those necessary things that I must have in order for those services to work, like networking, power, and cooling, right? It'd be really boring if you rented something and you had none of those three. Right? It'd be stupid. All right, so those are the things that you get when you use infrastructure as a service. Now, the one that, those two levels people are pretty familiar with. The one that's still somewhat of a mystery to people is the middle one, which is platform as a service. All right, this is where you've got something like infrastructure, but you got something a little bit more. Okay, and the thing is, it's really a lot more. All right. If you're renting virtual machines and disk, there are certain things that you have to be responsible for in addition to your application. You got to worry about the operating system. Do I run Windows Server? Do I run Linux? If I choose Linux, which distribution? And then once you choose a distribution, you got to pick kernel version. Those decisions have to be made. Then you have to decide what web server, what database server. Do I go with the traditional LAMP stack, or do I need something more specialized? So all of those decisions have to be made along at the same time as you working on your app. And those things are problems for every app, not just yours. Okay, so that's called cross-cutting functionality, right? So what platform aims to do is to kind of solve all of those problems for you and let you focus on your app. You don't worry about the operating system or the database server or any of that stuff. The platform takes care of that stuff for you, okay? So of course, App Engine is the subject of tonight's talk, but there's other similar systems, Azure from Microsoft, there's Cloud Foundry from VMware, they've spun that off. OpenShift from Red Hat. So we've got these 3 layers defined, and then of course in between each layer is a bunch of gray area, and so you can see the gray area typically is something like a database type of service or some sort of data service. All right, you can think of it as data as a service if you want, but so like BigQuery, Cloud SQL, those are all querying mechanisms. Google Translate, Google Prediction. There's also the Amazon databases and also Microsoft SQL Azure as well. So most of them are database services. They're more than infrastructure because you're getting more than hardware, but you don't quite get an application platform that you can actually build apps on, right? Those are building blocks. This gray area are building blocks that you can use in your application, but they themselves do not constitute an application, all right? And then similarly, between SaaS and platform, we have products like Google Apps Script and Force.com, which while they are kind of like a platform because they can host AppScript apps or Force.com apps, they're really tied to a particular vendor's information. Like Force.com you use to build apps to connect to your Salesforce data. Google Apps Script you use to write apps, JavaScript apps to access your data in Google Apps. All right, so those are like middle gray areas. Okay, so they're more than PaaS, but they're not quite SaaS either. They themselves provide you the ability to code. All right, so there's some kind of coding there. All right, the other cool thing I think that makes the platform really powerful is that at the software level, I just mentioned a minute ago that you don't have access to that source code. You can't control it. But with platform, you do. It is your code, right? In fact, you can think of it as you're using platform as a service platforms to create the next SaaS app with. That's really what you're doing. You're writing an app so that other people can access it online, and they don't have access to your source code. All right? So everybody on the same page now? You all know like which levels are at, so that when you get into these hallway conversations, you really know what you're talking about. All right? Because I think that's really important. Okay? All right. So let's talk about Google Cloud Platform. So the Cloud Platform encompasses things at the lower 2 levels. Okay, so of course Google Apps you can't code. For all you guys who are developers, this is where you can do the coding down here. Okay, so what is the Cloud Platform? The Cloud Platform is our integrated platform that provides multiple levels of multiple services, a compute service, storage service, and application services. I'll show you that on the diagram on the next slide. I already mentioned that it covers just the platform and the infrastructure levels. It really is just an extension of our own infrastructure. So before any of this ever existed, Google had to build all this stuff to run our business, right? We had to make things scale. We had to make search fast and reliable. We had to make Gmail work. We had to make YouTube work. All of those things we actually built for ourselves. And so now we're basically creating sort of like external endpoints so that you can access the same technologies that we've built. And since if you're running on a Google network, now you have access to other Google services and tools beyond the cloud platform. Okay, things like Google Apps and Course Builder, AppScript, and things like that. So I'll mention some of those tonight as well. And the best part is, as we make improvements to this cloud to make it better, to make it faster, to add more features, guess what? You guys get access to those too. Of course, we have to write the endpoints for them, and they give you the APIs, but as we find that certain features we think will be valuable to users, or you tell us if things are valuable, then we will go ahead and make those available for you as much as we possibly can. All right? So that's really what the main idea of the platform is. All right? So I mentioned there were 3 different pillars of the cloud platform. The compute side, so that's Compute Engine and App Engine. The storage stuff, which is where you put all your data, whether they be files or pure data. And also application services. So these are the 3 major areas. Okay. Also, I didn't want to leave this out, but you guys probably already know that Google has a worldwide network, so I don't really need to spend much time on this. Everything is well connected. They're all fiber. Everything's very, very quick, even to really remote parts of the world. I think that the last mile is usually where the bottlenecks always are. Okay. So bottom line is that we use this cloud to run our business, right? We want this business to keep going. We want it to be successful. We want our apps and our services to be reliable, to be quick, to be secure. So we want to give that to you guys, all right? So use what we use, all right? Build your software, run your business in the same place that we do, with the same scale, performance, security, and value that we built for ourselves. Really, I mean, we built them for ourselves, and guess what? Now we want to share that with you. All right, take advantage of all the years, all the man hours that we put into making this doggone thing scalable and reliable and fast and secure. All right. In fact, I think personally that scalability is the most difficult and the most expensive thing to build, because you got to hire really smart people. You got to really know how to measure performance as far as minimizing the latency for your app, being able to handle like sabotage and DOS attacks and things like that. All those things we've had to already worry about and try to solve. Okay, and we got a really nice quote from Wired magazine almost a year ago. That really describes, how we see our data centers as the core part of the company, and we really want to make some of these services available to you guys. All right, so tonight we're going to focus on one part of the compute pillar, all right, and that is App Engine. Okay, so that's really the background I wanted to kind of set. That's the backdrop. So moving forward, let's tell you about App Engine. All right. So if you were to build another app today, you got to do the LAMP stack. You're probably going to have some sort of database with a master and a bunch of slaves. You're probably going to have a bunch of front-end web servers, and then you're going to have some proxies to do caching and things like that. All right, but that a couple of things are missing from this diagram, which is like, what about failures? What about traffic problems and scaling? And I don't even think my app shows up in this picture. This is just the foundation that my app is going to run on, right? So there's a lot of things that you need to set up. And even if you've got things perfectly done, you've got this smart network architect, he built everything perfectly, that still doesn't mean that everything's going to work just right. Okay. So all of those problems that I mentioned, if you do like outsource all of your hardware and get infrastructure, so yes, I got virtual machines, I got storage, but I already mentioned you have to worry about the operating system, and then the web server, and then the database server. But I didn't even mention like configuration files, load balancing, monitoring, reporting, software licenses, patches, upgrades, license fees, right? All those things are things that you need to worry about in addition to your application. So the reason why App Engine exists was because 6-7 years ago, a couple of smart people at Google felt that it took too long to go from concept and code all the way to having an app that's available live around the world. And that was the problem they were trying to solve. And so hopefully all of these little brown boxes can be dropped into one large box called App Engine, and hopefully we'll give you familiar tools that you can use like Python, Java, PHP, and Go, that you can actually build these applications without changing your skill set too much. All right. The main idea is to let you focus on your app, not have to worry about the sysadmin stuff, not have to worry about the networking, the machines, and all that extra stuff, like I said, that is cross-cutting in relationship to your app. Okay, focus on your app, let us wear the pagers and take care of the system and all that kind of stuff. And so because of that, again, I want you to not get confused between App Engine and infrastructure services. So I don't want to hear, are you going to use App Engine versus, EC2? If you really want to make that kind of comparison, then you really should be talking about, let's compare Google Compute Engine versus Amazon EC2. That's probably a more fair assessment, all right? Because now both of those are at the infrastructure level, and now you can compare them, okay? But App Engine is a completely different beast because it handles so many things for you that we're trying to get you to market faster and not have to worry about this extra stuff that may slow you down, okay? All right, and if those 4 languages aren't good enough for you, because we have a JVM, we support a lot of other popular languages today, like Scala, Ruby, right? Those are good alternatives, right? Because we have a JVM. You can even run Jython too, which is Python, even though we have a native Python. I found that a lot of developers really like to use Jython because they have a lot of legacy classes that are written in Java, and a lot of their new development is happening in Python, but they don't want to have to port everything. So the nice thing about Jython is basically a Python interpreter that's written in Java, so that Python objects can talk to Java objects and move things back and forth, because everything at the bottom level is just Java bytecode. So it's a really good solution for people that, software houses that use both Java and Python, okay? All right, so one of the other tricky things about running in the cloud is, you're sitting next to a lot of other people who are developers here, but maybe you might not trust them with your source code or your data, right? It probably wouldn't be great if you could access other people's source code and their data, all right? And so in order to make things secure, we require that all of your applications run in a restricted environment called a sandbox. And in this sandbox, you can only play with your sand and your toys. You can't play with other people's toys. All right. This restricted environment does not permit you to do certain things, like you can't create a local file. You can't open an inbound socket connection. You can't make an operating system call, right? All of those things are security hazards. So those things are, the system prevents you from doing those things, all right? But the question you may be asking me is, well, gee, if I can't open a socket connection, I can't talk to another app online, I've got a pretty useless app, right? I can't really do anything if I can't talk on the network. Maybe I want to talk to another app that's running online, okay? Maybe I want to send email, something really simple, right? I want to open up, port 25 or something, okay? So the thing is, we're aware of that. Why would you want that low-level access, right? Because you're going to have to rebuild something that other people are going to have to build also. So why not give you a higher level API like the email API? All right, you can use the mail API and send messages. Even better is you can actually have your application receive inbound email and process it programmatically. Similarly, if you have to execute another app that's online, there's URL fetch. Okay, we give you a database. You can choose either the native NoSQL data store, or you can choose a MySQL compatible relational database. Right, you have two choices there. Of course, all of your data is distributed globally, so the writes aren't going to be as quick as the MySQL server that you have sitting on the floor in your office, right? It's not going to be that fast. So because your data is going to be global everywhere, if you want speed, we recommend that you cache as much as you possibly can. So use Memcache. Other services that you can get access to, we have a simple images API where you can rotate, resize, crop images. If you want to store large audio video files to serve, you can use cloud storage for that. We also provide authentication service, so either you roll your own authentication or you have no auth. Another option you have is you can require your users to have Google accounts and have them sign in with that. But if you want to be even more broad and be more open, we also have federated login, which allows you to have your users log in using OpenID. So they can log in either with their Google account or with their Yahoo or AOL or WordPress or any OpenID provider. Okay, so that gives you some flexibility there. Another restriction that I didn't mention, the other one I wanted to talk about was the channel API, which lets you maintain connections to the browser. And the reason why I'm mentioning the task queue and the channel API last is because one other restriction that I haven't told you about yet is you can't hog all of the resources. All right, there's other people running on the same machine as you. All right, you cannot run for more than 60 seconds. When a user at their web browser hits your app, you need to respond back to that user in less than 60 seconds. All right. You probably, as a human, you know that you can tell whether or not it's slow by even 1 second, right? You know that. So 60 seconds is way long, all right? But if for some reason you need to fire off, something that may take a long time, like you need to talk to other APIs, the Facebook API, the Twitter API, or you need to run like a large batch job somewhere in the background or elsewhere online, you don't necessarily have to be restricted to that 60 seconds if you don't want to, all right? So an alternative is to use the task queue. So we have different types of task queues, but the one that I'm going to describe lets you just fire off those background tasks using the task queue. Those things, each individual task can run up to 10 minutes, not 60 seconds, okay? So you have 10 minutes of execution time there. And the reason why the channel API is here is because if you fire off a background task, you really want to respond back to your user, right, in less than a second or so. Okay, so you can actually fire off a task, respond back to your user, but that doesn't mean you need to lose all connectivity with your user. All right. Maybe you want to tell them when that thing is done or when it's ready. Or maybe you want to refresh their web page or do something else with their UI so that they can tell something's been done. Well, that's what the channel API is, because that lets you hold on to a connection to the user's browser, and when that background job is done, you can actually send a message through the channel API, the channel that's connected to that user's browser, and take whatever action you need to. All right, so just because you fire off a background task to respond to your user doesn't mean you have to have bad user experience. Okay, so these are just 9 of the core APIs. There's almost 40 of them. There's way more than I can put on a slide here. There's like the MapReduce API, there's the search API that lets you index your data, whether you're searching for text or for timestamps or for geopoints for lat-long searching. Okay, so there's lots of other services that I don't have listed here, but these are sort of like the main 9. Okay, so we give you these higher level services to make up for what you can't get because you don't have the same full control over the machine that you used to. Okay, how does it work? It's very, very similar. This is not too much rocket science. We have, front-end machines that get the request, and then we have App Engine app servers that run your app, and whenever they need to talk to another service, like you need to request something from the memcache, or you need to send something to the data store, it fires off those RPCs to the back end. They do their work. They get back to the server, which responds back to your user. All right, so it's not exactly rocket scientist, it's not rocket science, but the thing is, it does require, what you don't see here is the scalability that's done automatically for you. All right, so it's auto scaling where you don't think about how many instances of your app are up. You don't really care actually. You just want your app to be working and responding to your users. All right, and that's really all you should be thinking about. Okay. Another thing you don't have control over is I can't log in and download my logs, right? I can't SSH into my box because there is no box because you've decided to, upload your apps to Google. Your apps are actually running in the same data centers on the same machines as what's running search and YouTube and Gmail and all those different things, right? Those servers you don't have access to. And so why would you want to log in and get your logs? Well, maybe you want to do some analysis, like what kind of traffic am I getting, okay? Have I gone over my free quota yet? All right, so the team knows this stuff. So we have a developer's console that shows you information about your app that you would otherwise have to build anyway. In fact, everybody that writes apps should be building something like this. But instead, we created it for you on your behalf so that you don't have to worry about it. So you can measure your traffic. You can measure your traffic rate. If you can see the numbers, if you squint really carefully, you can see that this number is about this app is averaging about 0.2. And the number is requests per second. So 0.2 requests a second means one user like every 5 seconds or so. And then there's a couple of peaks here, and it looks like it's peaking about 0.5. So maybe at the peak, it's getting like a user every other second. All right, so that's not a dead app. It's not exactly a hardcore viral app, but it is getting some traffic, right? It is getting some traffic. So that's one thing to kind of recognize. This is a pull down, if you could probably tell. But you can pull down a whole bunch of other charts too, like what's my error rate from my app? How many errors am I generating per second? Or there's lots of other different metrics that are measured with graphs that you can take a look at. You can also see your billing settings. You can see like how close am I to the end of the free quota? Have I gone over the free quota? How much have I budgeted? How much has it cost me today? So the daily cost, of course, refreshes every 24 hours, and we give you lots of knobs and dials so that you can actually tune your app and its performance to kind of control your budget. So this screenshot, I don't know if you guys recognize this, but this is from like 4 years ago. So today's admin console is way more complex than this. There are so many features on it that I don't really want to kind of overwhelm you, but this is the minimum of what you're going to get. If you take a look at your admin console when you get back, back to your office or back home tonight, you'll see that it has a lot more features here. But in this admin console, you can do lots of different things. Like you can check, what your full quota usage is, your billing settings. You can adjust that. You can set who are your developers who can upload new versions of your app, who can look at your app, who can operate in the admin console. You can take a look at your data through here. So there's all kinds of things that you can do from the admin console because you don't have access to the machines. All right, so we give you this in lieu of that. All right, so now we can talk about some numbers. Usually when you ask a Google employee, can you tell me, how much this, how much that? Usually we tell you, sorry, we can't say. So these are actually numbers we can talk about. Like, how many people are actually building App Engine apps? Well, there's more than 250,000 people who are developing apps, and this is on a monthly basis, okay? Of these 3 million active developers, they have more than 3 million active applications. All right, active means not the hello world you tried 2.5 years ago that no one's checking out anymore. All right, these are apps that are either getting traffic and or are getting new versions being uploaded, people checking into the admin console, things like that. Active, okay. In fact, half of all the IP addresses that are in circulation out there, public IP address, will touch an App Engine server every single week. Okay, that's not to say that App Engine runs half of the internet. It's that half of IP addresses touch an App Engine server. So what that really means is you may be using App Engine and not know it. Okay, and I'll give you some examples of when that may be the case. All right, how about those big numbers? Remember if you were to put all 3 million of these active applications together, how many page views or application HTTP hits do you think we get on a daily basis per day? Any ideas? How about 7.5 billion? Okay, all right, and in fact, all of the apps put together in a month will generate 4.5 trillion data store requests. And this is in the native NoSQL data store. This is not with the MySQL relational database. All right, that's a lot of traffic without going down as well, either. Okay, so those are just some of the googly sized numbers. Oh, by the way, we you know how like we release products, they always come out as beta first. Okay, the thing that actually caused us to sort of get over that and become an official product is when we passed 1 billion. That attracted the attention of some of our vice presidents. So they really won't notice you until you do something like a googly number like that, 1 billion, right? And so of course, Google products generally have 1 or 2 different ends, right? One is not so good. The other one is a wine and cheese party. So when we got the wine and cheese party, that was a good sign that App Engine was on its way to become an official product. And as of November of 2011, almost 2 years ago, it is an official product, which means it has to go through our normal deprecation policy and things like that. Okay, so those are some numbers. There's a bunch of users. I can't put them all on the page. There's just too many to list, but I will discuss a couple of them. Some are big names that you'll recognize, but it's while it may be true that most of Khan Academy runs on App Engine, not all of Best Buy or MTV or eVibe runs on App Engine. But some of them run a good chunk of stuff on a good amount of traffic sent our way. Okay. So I'm going to talk about some variety of different apps from different developers. Some are old, some are new, but just to kind of give you a rough idea I want to give you an idea of the scaling, and then I want to tell you a little bit more about current apps that are being built. Okay, so some of the older ones, one of them is, I want to talk about long-term scaling, all right? So we've got this app that's been around since the early days of App Engine. It's called Buddy Poke, all right? And it's a cutesy app. It's got avatars and stuff like that. It's probably not for my age group. I'm not. It's probably not for me, basically. But they have a lot of users. And in 2011, they actually had more than 64 million registered users. So the 62 number is from 2010. So the year after, they had more than 64 million registered users. What you should be thinking is, oh, that means they have more than 64 million objects in their data store. All right, so that's what you really should be thinking. All right. Other people will go, oh, I'm really skeptical. I don't care about registered users. Tell me how many people use this app every single day. All right. So back in 2011, when MySpace was around, Facebook and MySpace, I'll say I'd probably say that most of the traffic from MySpace has probably gone to Facebook by now. So roughly, I'd say 5.5 to 6 billion daily active users, people that log into the app every day. So that's not too bad, right? So that's one type of scaling, just a large, slowly growing data store. Okay. Another type of scaling comes from a different company called Gigya. And what they do is they build apps for very specific purposes, like some sporting event or a Hollywood movie promo. So their apps typically get no traffic, then all of a sudden they get an obscene amount of traffic, and then all of a sudden it dies, and then they go back and reskin that app for another purpose. And so here, do you remember that picture that I showed you from the admin console where they were getting like 0.2 requests per second and then peaking at about 0.5 requests per second? If you look very carefully at these numbers, they're slightly bigger than 0.2 and 0.5. Okay, this number is 400. So in your head, you're thinking 400 users per second accessing this app. All right, so it has no traffic, and then presumably some PR goes out for the event, and then people go to the website, blah, blah, blah. So it actually climbs pretty quickly within, I'd say within half an hour, it climbs to 800 QPS. So that's 800 browsers submitting a request to this app every second. And then the event looks like it starts right here. And then it ramps up really, really quickly now. And during the course of it appears to be about an hour's worth. In the course of 1 hour, it peaks at pretty much exactly 1,600. That's 1,600 users per second accessing this app without having it go down. And then you can see probably that the event ends just around here. And this event was if I remember correctly, it was a relief for the Haiti earthquake. It was a benefit for people who survived and to help things out. And so that was one example of an app that they did. Okay, just to give you an idea of the traffic. Now, if you want, so 1,600 users, that's a lot of requests, right? But let's say we want to get bigger, right? Because this is Google. We want to get bigger, better, more traffic, more traffic. And so beyond short-term scaling, I need to talk to you about royal scaling, okay? So this is the extreme case now, okay? So we all know that the wedding happened a couple of years ago. That's fine. It's finally had a result recently, okay? But their blog was an App Engine app, and on the wedding day, they got up to 2,000 QPS, 2,000 users per second hitting the app. And the YouTube live stream was also an App Engine app. Its number is slightly more than that. They had 32,000 requests per second, 32,000 users per second hitting this app. And that's a really giant number. And when the kiss happened, or the double kiss happened, it peaked at another 10K on top of that. So 42K QPS, which are 4 letters I don't usually say next to each other. Okay? It's an obscene amount of scaling, right? This ain't your daddy's cheap PHP hosting service. Right? That is not the purpose of it, even though App Engine supports PHP now. Okay? The purpose is to build something like this that won't fall down. That is really what you're getting. All right? If you want cheap PHP hosting, that's fine. You can go for that. It's going to be cheaper, honestly. Right? You're trying to create the next startup that goes viral. All right? An App Engine is a proper, appropriate product for that. Okay? So far, all the apps I've mentioned have been web-based, but guess what? Your UI could be somewhere else. It doesn't have to be web-based. Right? You could create a mobile app. Right? That's where your UI is. And if you want to give your users a good experience, you're going to have to store some data somewhere. Right? If you're a game creator, you make this awesome game, people work really hard, compete with their friends, get a high score. If they're students and they go to a party, things happen to their phones. If they have to replace their phone, get a new one, download your app again, log into your app. If they don't see those same high scores, they're probably not going to play your app anymore. Okay? Because that's not a great user experience. You really want to offload some of this stuff to a back-end service, have this data stored elsewhere so that people can check their high scores from their phone or from their desktops or whatnot, or a tablet or whatever. Right? So you really want to be putting things into the cloud. Okay? So you have a similar choice if you're building a back-end anyway. Either you're going to be doing it yourself and hosting it yourself, or you can rely on a service like App Engine, which all you need is HTTP to access your app. Okay? And give your users a much better experience. Okay? And this leads to what are some of those apps I may be using that are App Engine apps, but I don't know it. Right? Maybe I want to check the news. All right? There's an app called Pulse. I don't know if anybody's a user of it, but they're a very popular app. They're one of the top apps in the iTunes store as well as in the Google Play store. And they got a bunch of awards in 2011 when they launched, but still going strong. They have apps for Android, for iOS, and for Kindle. They have more than 30 million users, and people read more than 10 million stories a day. They get thousands of QPS, just like the non-royal wedding app. And they get more than 100 million requests every day. And they were kind enough to write a story for us in our blog back in 2011. But we really want to make mobile development easy. And so we have a tutorial and sample code to help you get started with that. And then I'll also mention another tool that App Engine has that is made for you to build your mobile version of your app easier. Okay, so I'll talk about that a little later on. Okay, there are other apps online that you may not be aware is App Engine. You know, even if you play the web version of Angry Birds, that web page has to be served by something, right? It's served by App Engine. All right. And those aren't the only apps. There's plenty more, okay? So as far as modern day apps are concerned, we have Snapchat. I don't know if any of you guys are familiar with this service, but it's sort of like Instagram, but the pictures disappear. So if you do something naughty over the weekend, you take a picture you want to share with your friends, but you want it to have a TTL, okay, that's what Snapchat is. It's a sharing of images that all expire. So, you know, the proof of your debauchery is not going to be long-lived. All right, they serve 150 million snaps a day. They're a big App Engine user. I don't know if you guys have played Song Pop. It's a very popular app, mobile as well as on Facebook. Basically, it's name that tune. You know, as fast as you can in the shortest amount of time. You guys probably can't beat me. All right, but they, along with App Engine, they also use Google Cloud Storage. All right, they serve more than 18 terabytes a day of music. All right, they have 80 million registered users with more than 1 million daily active users. All right, so that's another. So these are more modern day apps, all right, that are using the Google Cloud platform. All right, so now let's make developing the mobile version of your app easy. You've got an App Engine app. If you code in a very specific way, you can access Google Cloud Endpoints. And what Cloud Endpoints is that it takes all your code that you've put in nice, convenient places. It builds all of the boilerplate for you from your app, but it will also compile and give you boilerplate code in Java for your Android apps. It'll give you Objective-C code for your iOS apps. And it'll also generate some JavaScript if you want a mobile web version of your app. Okay, so the purpose of this tool is to make it easy for you to build APIs to your back office, the back-end version of your app that's running on App Engine, and to kind of get you started with the front end. So you can worry about the front end, but the back end is kind of taken care of for you. There's also a tutorial and some sample code that you can get here as well. Okay, so you can watch the 5-minute video, and then you can download the code and kind of get playing with it. All right, so that's the Cloud Endpoints. As you can see, based on everything I've run through so far, they're just a few examples of App Engine apps. There's so many more that I can't even, I don't have time to talk about them. Believe it or not, App Engine is really popular with dating sites. Who knew, right? Similarly, it's a very great platform to have students learning how to code web apps and mobile apps in schools because, we have I'll talk about pricing later, but we have a pretty generous free tier. And so you can even use it in research projects, or in fact, the school IT staff can use it to create apps to help operate the school, right? Same goes for enterprise, right? You can build enterprise apps with this thing. It's not just for web apps. It's for all kinds of apps, all right? So those are just some of the popular use cases that we've seen so far. Another thing that now to the management set of slides, all right? So obviously management, when I go talk to CIOs and CTOs. Besides, are there any educational discounts? Another FAQ I get is, what about vendor lock-in? Is Google trying to milk me for all my money and all my company's money forever? You would like to think that, right? My question is, have you ever known Google to be good at charging money for anything? I can't seem to find places to pay Google for anything, actually. So, maybe more drive storage, maybe more Gmail storage. I don't know. Anyway. To me, it's kind of hard. So we're not really after that. We're actually after a vibrant web ecosystem. Okay, and if there's more people online, more people using apps, there's probably going to be more people clicking ads, right? And that's how I get my paycheck, right? So that's what we're really after. We're not trying to milk you for all your money, all right? So what's lock-in, if you're not familiar with this term? It's basically where you have a system that makes it really hard or impossible for you to move your app or your data off of that system, and perhaps move it to a competitive system. All right. Does it apply to App Engine? Well, kind of yes and kind of no. And so when they ask me that question, they're trying to make it sound like, oh, Google's the bad guy. But I actually completely flip the tables over because my response is, wait a minute. don't you want to take advantage of Google, of all the R&D and all the man hours that we put in to make our system scalable, make it fast, make it reliable, right? You really want to give your apps that stuff without having you build it yourself. All right, so you're trying to take advantage of Google. All right, but the thing is, since we came up with a system, of course, we're going to be the first ones to develop an API for it. So yes, when the system first came out, you had to use Google APIs. But really, it's not in our DNA to try and milk people for all their money. And in fact, I'm very happy to say that our director publicly responded to people's criticisms of our system trying to do the lock-in thing. And so he pushes back just as strong as I do, and I'm glad that we're on the same page on this. So really, you should spend some time, take a look at his post, and I think it's really worthwhile reading to hear from senior management of App Engine, what their perspective is, okay? Just don't listen to me, the mouthpiece, right? You really got to hear it from management, okay? So you're trying to take advantage of our infrastructure. Do we need to write against the APIs? Maybe, all right? Does this make sense? Like, you're trying to take advantage of Google, right? So even with all this stuff, we are still trying to fight lock-in, all right? What are some of the different ways? Well, do you have to use Google APIs? Not anymore, all right? Do you have to learn new skills? You have to learn some new skills, but we really don't want to have you start from scratch. If you know how to write a servlet in Java, or you know how to use JSP, if you really want to do that, you can take your skills to App Engine. If you are a Python developer and you don't want to use the web framework that comes with the SDK, you can use Django or Web2Py or Tipfy, Flask, Bottle, Pyramid, any of those things. Those things you can run apps on App Engine. You'll have to probably download another piece of software to make it happen, but it can happen. I already mentioned earlier, you can choose between our native NoSQL data store, or you can choose our relational MySQL compatible data store, all right? Maybe you don't want to do any SQL at all. You just want to do objects, all right? Well, if you program in Django, you can use Django's ORM. If you use the MySQL compatible Google Cloud SQL, you can use Django pretty much straight up and just make sure your settings file is really the only thing you have to change. But you can also use it with our non-relational data store too if you download a third-party app called Django Non-Rel. Similarly, if you're a Java user and you're familiar with JDO or JPA, you can use those ORMs as well, all right? Or you can use something a little lower level like Objectify, that works perfectly. All of our SDKs are open source, so if you really want to, you can reverse engineer, App Engine's or APIs if you want. All of our Java APIs, we try to make them stick to as close to the JSR standards as much as possible. With Python, we pretty much just have you write against the standard library. All right. We also give you a data store bulk loader to easily upload or download all of your data. Now, if you have a lot of data, it may not be the world's fastest thing, but you can put your data in and take it out at any time. All right. And even then, maybe you're in a situation where you're working for an employer where you can't have Google hosting apps or data. It just must run in your own data center. All right. There are actually open source backend systems that claim to be fully API compatible with Google App Engine. So you can actually take, in Python, there's two of them. One is AppScale, one is Typhoon. In Java, it's Cape Dwarf. All right. You can actually run these in your own data centers, on premise or like in your colos. All right. And so that way, you're completely free of Google, right? So you can take any of your App Engine apps that you wrote before, that you ran on Google before, but you can now run them on your own. And here's an even funnier story. Well, maybe it's not funny, but to me, I think it's funny because AppScale is actually a project from UC Santa Barbara, which is where I went to grad school, but I had nothing to do with this project because it came afterwards. And because they're a university research project, they actually applied for a research grant from the Google research team. And guess what? They won. They won a significant award to build this thing. So in a sense, you could say that Google is funding its own competition because we are so against lock-in. Okay? So it's really not part of the company's DNA to do that type of stuff. It's just not part of the culture. Okay? So that's lock-in. Now, of course, we have to get into pricing because we're in the management set of slides, right? So it's free, all right? We have a pretty generous free tier. And when I say generous, I mean that you could probably run your small business or your church website off of it without having to ever pay Google a penny, okay? And if you do go over your free quota, then you just pay per use. Whatever you use beyond the free quota, whatever is pay per use. Like if you use a little bit more networking, I think it's like 12 cents per gig. of data that you send more, so you have all these little incremental costs. If you want to have support, you can go for one of the Premier services. All right, there's more information on pricing at the link there, but with Premier pricing, you can get some support. Okay, so if you need to get a response back in a certain time frame or whatnot, you can do that. So it starts at $150. If you do any kind of paid service, you'll get an SLA, which is a guaranteed uptime. Okay, and of course, there's extra fee for other custom things that you want, like maybe your own domain SSL, things like that. But like I said, you can pretty much get started for free. All right. Again, more management stuff. Some folks are worried about compliance. All right, so we are SAS 70 compliant, as well as compliant to its replacement, which is SSAE 16, and the international version of that, ISAE 3402. And we're also ISO 27K compliant as well. Some folks also have a restriction that your data and your apps must be hosted within certain geographical boundaries. So you can actually choose to have your apps be based in the US or based out of the EU. Okay, we're expanding our global footprint. So we started with North America base, and now we've moved to Europe, and at some point we'll hit other parts of this globe as well. Okay, so the roadmap is available online for you here, and some of the things that we're working on. Get a drink here. Include support for Java Servlet 3. Migration of blob store, so we're migrating everything over to Google Cloud Storage from the old blob store that we had originally. And I think one of the most exciting things that we have in the pipeline is a VM-oriented runtime. Okay, VM runtime means you can have App Engine managed backends. So we use Compute Engine VM. So if you have code that can't run within App Engine's normal restricted environments, you can actually spin off some of that code to have it run in a VM on Compute Engine. So that's pretty exciting. And of course, more deeper integration with Compute Engine itself, as well as other cloud services I'll mention briefly in a moment. Okay? So that's what's on the roadmap. By the way, we're not really good at vaporware either. So if it is on the roadmap and it's published on the website, that means there's at least one engineer working on it. Okay? So code is happening. All right, so you're excited about App Engine, hopefully. You're ready to get started. Where do I go? What do I do? If you want to read more about product information, in other words, the marketing page, you can go to cloud.google.com/products and you'll find App Engine there. If you're a developer, you want to immediately start checking out the docs and downloads, go to developers.google.com/App Engine. If you want to start creating App Engine apps already, go to appengine.google.com. If you want help from experts on anything technical, including App Engine, obviously Stack Overflow is the way to go, but we also have specific tags for each of our cloud products. So if you want to ask an App Engine question, you can find the App Engine tag. Same goes for our other cloud as well. Okay? And not only are there experts in the field that look at them and answer questions, but also Google engineers will look at them and answer questions too. So everybody's participating, all right? There's a blog that you should follow, and we also have social endpoints, which are our Twitter account and our Google Plus account. Okay? Some of you guys may be teachers, or you may be trainers, or you may be tech leads that want to train your employees how to use our cloud. So what about teaching materials? Guess what? We have that too, because if you're interested in teaching App Engine at work, or if you work at a university and you want to start teaching it, do you think you have to go and investigate App Engine from scratch, come up with your own examples, come up with your own teaching materials? You used to have to worry about that, but I took care of that for you. Okay, so I and a bunch of coworkers on the cloud team have built a bunch of classes. You can see they're all categorized according to product. Some of them are beginning to become cross-product now as well too. So you can actually learn how to use multiple Google APIs simultaneously. So we're slowly, and I emphasize slowly, adding new things every day. But I try to get the teams to kind of refresh their material, to kind of keep things up to date and things like that. And then we're also, this is currently just static content, but we're going to try and do more, like add more slide decks, add videos and things like that. So those things are all forthcoming. So kind of keep your eyes and ears tuned. But at least there's some foundation there in case you are a trainer or you're a TL of some sort. Okay? All right, now, so I mentioned earlier there's a way to get started with App Engine without any downloads whatsoever. Okay, and that is the Cloud Playground. So just go to cloud-playground.appspot.com. And what you'll get is you'll get a list of projects that you can clone. And you can clone anything. Here I've cloned the basic Hello World app, which you would get if you downloaded the SDK anyway. but I'm in a browser that I have no other connectivity to anything except for this website. I can bring up App Engine code, I can edit it. See, it's printing hello world now. If I go and fix the code, like maybe I add an H1 tag and change the hello world to hello y'all, and click the little green run button, I can actually see the change reflected in an iframe down below. So you actually pretend you're doing App Engine development. You can pretty much do all of the getting started tutorial directly in a browser window from the cloud playground. So I really encourage you guys who are really, really new to this, if you're not sure you want to go and download the SDK yet and play with it, really try this out. Okay, because it doesn't cost you anything. You can create projects, delete projects. We have a whole bunch of projects you can clone. So if you are looking for something very specific, try and find a project that closest meets the needs that you have, and then clone that, change the code, tweak the code, do whatever you want. And then one thing that's missing is there's now a download zip file button, so that all the code that you do play around with, you can actually take it with you, and you can download the SDK, run it on that, and then you can choose to upload to all of that to production, to Google if you want as well. Okay, so it's a really flexible tool, fun, and we're adding new features to it every day. Okay, so that's the cloud playground. And that's really all I wanted to say about App Engine. All right, so let's move on to the last piece, which is the other cloud components. All right, so of course I'm going to talk about the Google Cloud Platform more, because that's really the main product that we have now. App Engine is just a sub-product of that group. So I want you to become more familiar with what all those other products are. And then we'll talk about other services and software that Google has that's available to you. Okay, so App Engine is really the gateway to getting to other cloud services. I mentioned that you have access to a relational database, which is the MySQL compatible Google Cloud SQL. If you choose to use the native NoSQL data store that is now available externally to you, it's the Cloud Data Store. Okay. We have Compute Engine, so if you run virtual machines, they're there. Cloud storage is also another entry point. That's where you basically put all of your data. All right. It's the large, big disk. Okay. Some people get confused between Google Drive and Google Cloud Storage, because Google Drive is also a form of cloud storage. The main difference is Google Drive lives sort of within the apps universe, so which you can also use App Engine to create apps for your Google Apps domain too. All right. But back to the question about Google Drive versus cloud storage. Drive is more used for apps, for your documents, for sharing with other people, for collaboration, and for syncing to multiple devices. Cloud storage is for your 5 terabytes of data that you're not going to put in Google Drive, right? It's not for a document, it's for your data warehouse. So that's pretty much the main difference between the two. At the very bottom layer, they may all use the same Google technologies in the end, but their purposes are different. Okay, so I just want you guys to be sure of that, the difference between the two, especially if somebody else asks you that. All right. We also have Google Translate, Google BigQuery, and Prediction. All right, so let's talk about some of these other cloud platform products. All right, so let's just say you can't run within App Engine. I need to have a socket. I need to have an inbound socket because I have some HR apps that are talking through the firewall. I need to have that. All right, so you need VMs. And so Compute Engine are on-demand VMs. We support Red Hats, CentOS, Debian. You can have between 1 and 8 cores. You can have between nearly 2 to 6.5 gigs of RAM per core. And when you create your virtual machines, they all run on a private network. So they're actually talking to each other without having internet traffic get in the way. And you can specify whether certain machines have an endpoint that is accessible from the public internet, or you can just choose not to. You can create your own sub-network within that. You can create firewalls with it. All right. There's various types of storage. All VMs will get a local scratch or ephemeral disk, 400 gigs in size. There's also the awesome persistent disk, okay, because your local scratch ephemeral disk will come and go with your VM. So if you bring up VMs and bring them down, those scratch disks will go away. But maybe you have a distribution with all the packages that you want on it, and you want all your machines to use the same one, but you don't want to have to download all those packages every time you create a VM. All right, put them all on persistent disk, because persistent disk will survive the comings and goings of VMs. All right, and you can mount them on multiple VMs as well too. Mostly read-only, of course, but that's the power of persistent disk. And then we also talked about Google Cloud Storage, which is the large-scale storage stuff. There's 3 different ways for you to get to your VMs. You can use our command line tool, you can use a web-based interface, or you can programmatically access your VMs via REST API. You can create VMs, you can destroy VMs, all using JSON payload. Just send it over. You'll do it. You can track progress. All right. Lots of cool stuff about Compute Engine. I think it's a really good alternative to people who are used to only from 1 or 2 getting VMs from 1 or 2 vendors. Now you have another choice. All right. And so GigaOM published a blog post from Scalar, and they did research against one of the competition, and it seems that Google Compute Engine has pretty good latency. We have a fatter pipe, and one of the coolest things is the instances are really, really quick. Generally, when you create a VM on Compute Engine, you can SSH into it in about half a minute. All right, they really come up fast, and they go down quickly as well too. All right, so definitely explore that. If you're using VMs from other vendors, you should really give it a shot and do your own benchmarks. Don't necessarily listen to us or from a third-party vendor like Scalar, but there is some. It's good that at least they're a third party and they're not owned by Google or something like that. But you guys should definitely do your benchmarks too, and we want to hear it. Please send me any reports on any bugs you find, any features that you're looking for, any success stories you have. I'm very happy to send out T-shirts to people. All right, I'm sure you're happy to receive T-shirts as well, because most developers, we live off of T-shirts. All right, my companies all clothe me, much to the dismay of my wife. Yeah, anyway, I'll be happy to send you guys a shirt, all right? So some other things. We already talked about cloud storage as well. Very fast, scalable, highly available object store. As soon as you write an object and get acknowledgement back from Google, anybody can read it. So it's strong consistency, all right? Very flexible authentication. We use OAuth, and you can have access control lists to determine whether it's an individual, a group, whoever can get access to your objects. You can access it from REST API through App Engine's API, really the cloud storage client library, Web UI or command line. Cloud SQL, I already talked about. That's our MySQL compatible relational database in the cloud, also accessible from App Engine or externally via JDBC. We also have the Cloud Data Store. I mentioned that is our NoSQL database built at Google scale using a very low-level interface. You access via HTTP. And if you are familiar with the native NoSQL data store from App Engine, that's what this is as well. Many of you probably already know what Google Translate is, but guess what? You can actually access it programmatically. So you can write bilingual apps or apps that do translations as well. Okay, also using a familiar REST type interface. Okay. A couple other ones. There's Google BigQuery. So this is where you can issue a SQL query across multiple terabytes of data. All right, something you can't quite do with a relational database today. And if you can, you may have to have a relational database that's sharded multiple ways, and you have to kind of like do your own manual map reduces to be able to get that data to a size that can be, digested by our users. Or it may take extremely long time to run those queries. So with BigQuery, you can actually issue SQL-like requests to BigQuery on multiple terabytes of data and get results back in seconds, not hours and not days. All right, it is very, very fast, and it's great no matter how big your data is. All right, so you should really give it a shot. In fact, we created a cool little app that you can take a look at by going to this link and checking out the tour. All right, so it's a good way to kind of get a sampler for how BigQuery works, the kind of data sets that you can use. And then you can start playing around with some of our free public data sets. You can have fun with like finding out what are the most highly changed Wikipedia pages, or what are the most common words in all of Shakespeare's works. Or, you can even, we even have the U.S. Health and Human Services neonatality database. So you can dig deep and ask a question as precise as, what is the mortality rate for children born to mothers between ages 25 and 29 from 1957 to 1962 who were smokers? All right? You can ask a question like that to BigQuery, and it will give you an answer in a very short amount of time. Okay, so play around with some of those public data sets. It's really fun. And then we also have Google Prediction. That is our machine learning service in the cloud. So if you're familiar with AI and machine learning, you may be familiar with the supervised learning type of algorithms, which is what we support right now. Basically, the way it works is you train models and get predictions. Some people who have never seen machine learning before may think it's magic, and it kind of is, because you're uploading some data and then you're just asking the prediction API, what is this, and it'll tell you. All right, so it's pretty cool to look at. You can use it for lots of different things like sentiment analysis. You can do spam detection, all kinds of crazy things. All right, so take a look at that. So that's really the cloud platform. So now on to the rest of the talk, which are non-cloud platform products, which you may be interested in thinking about. One of them is Fusion Tables. So that's sort of like a combination between Google Maps and some kind of spreadsheet. You can think of them as being able to take data that's in one or more spreadsheets and being able to visualize it. So something like election data or maybe the health data. It was also used to sort of track when the Haiti earthquake did happen, it was used to track which facilities have medical supplies, what kind of patients can they accept here, because what kind of medicines are at these medical locations. So you can map all kinds of things. If you can put it in a spreadsheet and you can visualize it, you can use Fusion Tables for that. It's pretty easy to get started, so you can just take a look there at that link. Okay. Another tool that we have, so Fusion Tables comes out of the Fusion Tables team, the Google Research team there. Google Research also built something called Course Builder. So you probably have no doubt heard about all these well-known, massive open online courses and learning content, created by Khan Academy or Udacity, Coursera, edX, all these big-name vendors, Codecademy, all right? And maybe you want to offer your own massive open online course. But you don't want to have to rely on a third-party vendor like a Udacity or something, right? So the Google Research team built their own MOOC software, and they've offered several courses with it. The first one is the power searching class. You didn't know that you could actually make your searching better, did you? All right, take the class and you'll find out lots of different new ways of doing searching that you've never known before, all right? But this software, Google Research has built and made it available as open source. It runs on App Engine. Now that you know what App Engine is, you're very familiar with it, and you don't have to worry about scaling for your massive open online course. All right. So it's open source. You can download it there. You can read our launching blog post, or you can take a look at the first class or any number of our classes that we're offering through using Course Builder now. Okay. So now that you can offer classes online, what about course registration? So the Google corporate engineering team had to build an app to help us manage all of our internal employee training. Okay, so internally we call this glearn, but guess what they did? They took this code, it runs on App Engine as well, and they made it open source. So a couple years ago, they announced this at Google I/O, and they gave a talk on it. And you can access the code there, and you can handle course registrations. You can say, I can only take 200 students, or they need to have manager approval, or only employees, no vendors, contractors, and things like that. So there's a lot of business logic built into it as well. Instructors will get access to the course roster, and they can email them. So there's lots of different things that you can do with it. And both Cloud Course and Course Builder, like I said, are all open source. So you actually control all the code. You can customize it any way you want. If you want to submit a patch back, I'm sure people will be glad to look at it. But so these are two other services that Google has. AppScript. How many people know what AppScript is? Oh my gosh, that's grim. That's less than 8%. Okay, you have to know what AppScript is. All right, you gotta try this because it's crazy amazing. All right, so AppScript is JavaScript out of the browser and in Google's cloud. All right, so you know how with Node, you're already executing on a Node server, not in a browser? Well, this is yet another way you can execute JavaScript. It's JavaScript that executes in Google's cloud, and we give you an IDE that you can actually code in directly, but it's deeply integrated with Google Apps and other services. You can do things like automate repetitive tasks. You can manipulate data across multiple Google apps. And so how does it work? So I'm going to show you 4 lines of JavaScript. 4 lines, that's it. 4 lines of JavaScript code that touches 3 different Google products and is somewhat useful. Okay, so after this, I'm hoping that you guys all go and try some AppScript as well. Okay, here are the 4 lines of JavaScript. Before we get started, let's have one assumption, and that is I have a Google spreadsheet, a Google Sheet, and it has addresses in it. Okay, so we'll start from that point. So we've got the spreadsheet. We've got addresses in it, okay? Everybody okay with that? Now let's look at the 4 lines of JavaScript. Here's a function. I'm going to connect to Google Sheets and get the active spreadsheet. So that's the whole spreadsheet. In the second line of code, I'm going to say, hey, give me what's in cell A2. A2 happens to be the address of the Google New York office. All right. Third line, I'm going to call Google Maps and say, create me a brand new map and drop a pin at that address that I just pulled out of the spreadsheet. Boom. Last line of code, I'm going to call Gmail and email this map to my friend. Right? 4 lines of code, 3 different Google products. It's pretty useful. All right? Now, the colleague of mine who works on the AppScript DevRel team, he has another cool example where he'll actually he'll connect to Gmail, get the top 10 most recent subject lines, and he'll go and call like Google Translate and translate them to Spanish. Right? So you can do all kinds of crazy things touching on various different Google services, right? Pretty useful. I hope a lot more people raise their hand the next time I ask this question. Right? You guys should really try it out. If you guys are, I've in the past I did a lot of COM programming where I did a lot of programming with like Microsoft Office and like Excel, PowerPoint, things like that. So I used to use COM for that. So this is sort of like something similar for Google Apps, right? It's Google Apps Script. Okay? Don't call it GAS. The team doesn't like that. Okay? Google Apps Script. Also, Apps has an S on it. App Engine does not have an S on it. Also, App Engine has a space in between, except for the Twitter hashtag. All right? Spell things correctly. All right. Once you are familiar with Compute Engine, App Engine, you now have a foundation to start touching other Google APIs and adding way more interesting features to your apps. You can start adding maps from using the Google Maps APIs. And we even have mobile versions of Google Maps APIs. So now that you can have a mobile app where your user does not have to exit your app to launch Google Maps to use it. You can actually integrate Google Maps features into your app. All right. You can use the YouTube API. All right. Channel 7 News up in San Francisco. They have a YouTube app where if you're out and about and you see news happening, you can actually film it on your phone, and then you can use their app. They'll automatically upload to YouTube and then send a link to the TV station and have you sign all the necessary releases and all that kind of stuff. Right? So that's one way you can integrate with the YouTube API. You can do all kinds of other things with the YouTube API I don't have time to talk about, but there's also Drive. Oh, by the way, have you guys all used the Google Docs feature or the spreadsheet feature where multiple people are all logged in at the same time working together? Okay. Google Drive has a real-time API so that you can build apps that let multiple people log in and use your app simultaneously. All right, so you can get the same goodness as well. It's pretty awesome. All right, you can use Go. You can learn Google TV. You can do Google+. You can do Android, of course. Learn Dart and Polymer and all these cool new features that we have. HTML5, Google Wallet, you can monetize. All right, so really what I wanted to present to you tonight was a foundation of what things, what you can build your app on top of, and now all of the other APIs are things that you can use in those apps that you're building. All right, so that's that. And keep an eye on our blog. All right, so the developers blog is where we have announcements, pretty much multiple announcements every week. This just happens to be the one that I did when we launched the Academy and another program called the University Consortium, which is a place for university faculty who are teaching, with Google technologies to kind of collaborate with each other. Anyway, keep an eye on our blog as well as the Google Cloud blog. Most of the time we cross-post as well too, so you can keep an eye on both if you want. But the developers blog is the general place where all of the different product teams announce, new features and things like that. Okay, and that is pretty much it, except for one more thing. We want to give you guys some money tonight. Is Becca here? She's taken off. All right. We want to give you guys $2,000. Every person. Not cash. Okay? Sorry. It is an Oprah moment to be able to use Google Cloud for no charge. All right? So, developers from affiliated partners, the GDG is considered an affiliated partner. Okay? The Google Cloud marketing team has come up with a $2,000 package where you'll actually get this amount credited towards cloud usage. You can use up to $1,000 for App Engine, Like I said, the free tier is so generous, you probably won't be using much of it. But the other cloud products don't currently have a free tier, so you will be using that for Google Compute Engine and all the other cloud platform products that I talked about. All right, so for just the GDG members, apply now. Google Cloud, Cloud Google Home Starter Pack, and then use the promo code GDG-IN. Okay, and here is a startup, a founder of a startup that said this starter pack is pretty cool. So I think you guys should give it a shot. Play around with all these different cloud platform products. Send me questions, bugs, feature requests, success stories. Who knows? You may be featured on a Google blog one day. Okay? So talk to me. And the way you talk to me is you can connect to me with Google+, email, Twitter. I have a blog for my Python work and also for my books. I have a website for that. And then Cloud Platform has a website, a blog, Twitter handle, and also a Google+ as well. All right? Thank you very much for coming, everybody. I hope you got a lot out of it. Are there any questions? Oh, wait, I need your help tonight. For those of you who are willing to stay late because you want to get a tech talk and a piano concert. Okay, so I'm going to be going across the street in about half an hour. I'm going to be playing some Chopin. I'm going to rock some Chopin across the street. So if you guys aren't busy, I can only take X number of you that Google Security will allow me to take. But I have a performance that I'm doing this Saturday or this Sunday. I can't remember, Saturday. And while I can play this in the dark at home, I need to have pressure. So if you're willing to listen to a Chopin etude, just follow me a little later. Just hang around, all right? In the meantime, are there any questions? Not about Chopin, but about what I talked about tonight. Yes, sir. So the question is, you can either go to the mic or I can repeat the question. So the question was asking, how do I integrate with OpenCV? Now, I'm not familiar with OpenCV. What is that? Computer Vision Library. Okay, so I think I know what the question is. Basically, the question is, can I upload my code and have a third-party library execute on App Engine? Okay, so the answer is yes. If it's pure Python, it doesn't use any restricted libraries, and it doesn't have any C code. So no C, so that's going to be a tricky thing, all right? I don't know if that's really bad, but maybe the whole thing is C, right? The whole thing is C, so it's going to be trickier. In the past, we've been more restrictive. So in the original version of App Engine with the 2.5 runtime, we did not have lots more things. But with the 2.7 support, we're trying to relax some of the security requirements. So now we actually support NumPy. We support LXML. You know, all these things used to be kind of verboten, but now they're allowed. But if it's still C, we still can't do that yet. But if it's pure Python, usually it's pretty reasonable. Okay, good question. Another question. Oh, come on. Okay, we'll try you again until somebody else has worked up the nerve.
One thing that's been kind of tough with GAE is integrating it co-op together with Facebook, so you go and have one universal sign-in for every module, one really special support. You can repeat the question.
All right, so the question is, we want to implement single sign-on. It's usually been pretty tricky with OAuth and all that kind of stuff. Yeah, you know, security is always going to be a little bit of an issue, but
Google, you know all about that stuff.
we do. We have people that know a lot about that stuff. Yeah, that one I'm going to have to check with our security team on. We had the Google Identity Toolkit a little while ago. I don't know if that's still current or not, but I know another developer advocate on my team who can better answer that question than I can.
Yeah, I was going to say, look up Tim Bray.
Yeah,
So
it's Tim Bray. Everybody knows who he is. Just contact him.
Bray. Look him up on Google+. He talks a lot about identity-related stuff. He might even have I don't know if his talk was recorded at OSCON, but he's given a talk.
Yeah, you know, so that sort of Van does remind me. So Tim did give a talk on identities and authentication at OSCON, which is the O'Reilly Open Source Convention. You may be able to get a slide deck online. I do not believe they recorded the talks, though.
Besides the slide deck, you have like a library that you can use that does the job, or do we have to?
Without trying to be Tim, it's complicated because, I mean, if people follow certain standards, then there's libraries you can use that work with those standards, but there isn't one standard that everyone is on board with. So there's the OAuth, different levels of that, and OpenID, and your flavor of the month. So
yeah, I mean, the answer really is it's complicated because it's security. All right, anybody else? Question? Did it just overwhelm you or something? Or was this talk too low level? You want to see code or something, or what? I mean, come on. Boring. Okay, yes, sir. Can you debug remotely? Great question. Depends what you mean by debugging. So a couple of answers to that. The SDK that you download, it does come with a local development server. So you can actually run your code locally on your box and debug there. As far as debugging remotely, you know, you'll get error messages, you'll get exceptions thrown at you, and you will get stack traces, and you can access those from your admin console. You can also download them as well. Better yet, there is a tool called AppStats, AppStats, which will let you actually measure performance between your app and the back-end services that you're calling, like Memcache or task queues or whatever. You can actually track and follow like what are the bottlenecks in your code that's causing those things to happen, and so you can better, you know, you can refactor your code so that it performs better. I mean, that's not necessarily related to bugs, but it's partially it. Okay, great. There's also unit testing frameworks as well for your App Engine apps too. Okay, so lots of different tools that you could use. Yes, sir. Yeah, how do you, so the question is, how do you develop beyond one person? So that's a great question. So obviously, when you create an App Engine application, you create it as yourself, as the user, but there's a couple of ways of going beyond that. If you're using a Google Apps domain, you could specify people that are in the apps domain that can get access to your app. You can also physically opt in people, like you can send them an invite to become a developer on your app. There's also different roles. So you could say someone who's the owner, or someone who's just a developer, or someone who can just run the code or look at the code or not do anything else with it. So there's multiple levels of control. Okay, great question. Anything else? Yes, sir.
Are the servers and databases compliant with like certain like government confidentiality stuff, like HIPAA compliance or?
Yeah, so I can't really speak to other types of compliance, but the ones that were mentioned in the talk are the ones that we can talk about. All of the other ones we know about and we're working on, but we don't have anything to say today. Okay, great. So for people who are concerned about that kind of stuff, typically the use case is, you know, if I've got patient data and I'm really worried about HIPAA, what customers typically do is they do the encryption themselves. So it's already encrypted by the time it comes into Google's network. So then it's never a problem for us because we can't see it. Okay, great. Yes, sir.
You mentioned, you know, how far you can scale it with, you know, 16,000 requests per second.
Right. Right.
If there was a scheduled time for my app and 1,000 people come on my app at that exact moment, like say, I don't know, registration for Google I/O.
Don't mention that. There were no bugs in our software when registration for I/O when it launched. It was bugs elsewhere. Okay. So the question was, how do we get to that obscene type of scaling? Does it ramp up? Is it like a floodgate type of thing, like I/O registration? A couple of ways for me to answer that. One is that the App Engine service actively monitors your app. So as your traffic grows, it will actually create more resources to be able to support the traffic that you're getting. So one of the things is the amount of traffic that you're getting and the growth that's happening. Another thing that's important related to scaling is one of the best practices. It's actually part of my best practice talk on App Engine, which is try to have your app respond in under 1,000 milliseconds, okay, under 1 second. The faster your app responds, the more willing the App Engine system is to automatically scale your app and just stretch you out horizontally as much as you need. The slower you are, the more that you'll be penalized. Okay, so if you have apps that, if you're naughty and you're taking several seconds or 30 seconds or something really bad, you get put in the corner. You're getting demerits, right? So those are ways to get it to scale. Another thing is if you're working if you're working on a really large app where it really matters, and if you have a developer advocate that you're working with that's on the cloud team already, they can help you with developing strategies for load balancing and also load testing and things like that too. And if it's really a big public event, then it may be possible to have your advocate kind of like talk to the team about maybe there's something that's really, really big that we can maybe help out with on our side. But as far as taking care of the system goes, the engineers are responsible for making sure that the system is up. We'll never look at one particular app. Even when the royal wedding happened, they would not monitor one app. They monitor the system as a whole. It was those of us who are public facing that were freaking out, staying up late at night, monitoring the app. They were not monitoring the app. I was, okay? So we don't do monitoring at that level, but ramping up slowly works fine, ramping up quickly works fine as long as your app responds quickly. There's a couple of things that you can do to help your app respond more quickly to more traffic as it comes in. So you can look up warm-ups. So you can actually prepare an App Engine instance before it gets any traffic. It can run some code to prepare itself, like loading some jar files or whatnot, and get it so that by the time traffic hits it, users will not notice the difference between hitting that new instance of your app versus one that's already been up and running. Okay, so those are just some answers. There's probably others that I don't know. I haven't been on the team for quite a while now, but tried my best to answer it. Any others? Oh, yeah.
How do you deploy that?
How do you deploy the app? That's a great question. So there's 2 different ways of doing it right now. You can do it from the command line, where you just give the appropriate command to upload your app, and then you have to give your credentials and things like that. And it'll upload your app. It'll tell you, like, have we finished uploading your app yet? And then it also, once it uploads your app, it also has to make sure that your app is serving before you get control back. So typically, I would say normally your app should be up and going in about half a minute or less. It shouldn't take too long, maybe up to a minute, depending if the system is busy or whatnot. The other way of uploading your app is from the UI tool that comes with the SDK. So if you're on a Mac or a PC, it comes with a tool called the Launcher. You just click on the deploy button, type in your credentials, and it'll upload your app there. Okay, so those are 2 different ways of doing it. Pardon? Yes, right. We also added Git push to deploy as well too. So that's the 3rd one. Sorry I didn't mention that one, but yes. Which may be the more modern way of doing things, actually. Yes, sir?
How does the CPU time compare between using Jython or Python?
How does the CPU time compare between using Jython versus Python? That's a good question. That is something that I haven't measured before. At the very bottom level, it's all C code that's running, even Java, right? So everything runs at sort of, at an even level. So it's not like, some people think, oh yeah, if it's compiled code, it may run faster than if it's not compiled code, but everything is bytecode compiled already. So if you've got a Java app, whether it's a Jython app or a traditional Java app, the Java bytecode is compiled before your app runs. Same thing goes, actually, when you upload your Python app, all that stuff is compiled to Python bytecode as well, too. But I haven't done any benchmarks to see. But that's something that's worth trying, though. And if you do that, contact me and let me know what your results are. All right, thanks. Yes, sir? How much memory do you have? That's also something else that's not within your control. If your app starts using too much memory, you'll be getting some exceptions to telling you that. There's no real ballpark number I can really say, actually, because it's just something that really shouldn't be something that you need to worry about. I don't know if we have any memory management tools to help you with that. Yeah, that's just one of those things that that's taken care of for you? I know that's not a great answer, but if you have something more specific that you're asking about, like maybe certain libraries, you want to know how much memory you have, you can check with me on that. The other thing that's not predictable, that is a question that you did not ask, that is related, is how much memcache do you get with the memcache service? That's also not predictable too, because it's a shared service and it all depends on your usage and other people's usage. But we also, we're working on a more dedicated type of memcache that you can kind of control on your own. So that's something that we're working on. Okay, great. Anything else? All right, great. Oh, one more. Yes, I'll get the slides over to Van or Kevin and you, Tom, or Peter, and we'll get them available for you guys. All right, thanks for coming, everybody. Hang around for piano stuff. Yeah. What? Oh, I'm just playing one song.